Hi, I'm John, the Twisted Cuber. Today I'm going to show you how to solve the 4x4 checker cube. Before we begin, I hope you hit the like, subscribe, and notification buttons. Let's get started. In my unboxing video for this puzzle, I was under the impression that this puzzle could also be used as a Sudoku cube. My mistake. It cannot. This, however, can. You should know how to solve the 4x4 before trying to solve this puzzle. If you don't know how to solve it, I've placed a link to my tutorial on it in the description below. Let's scramble this up. Okay, the puzzle is now scrambled. This puzzle solves much the same way as a 4x4, however there are some differences. We'll start by building the centers. Now, unlike a regular 4x4, which centers are a solid color like this, the centers on this puzzle will be alternating in black and white. Like this. I will build the centers in the same order that I would a regular 4x4. So far, so good. Got a couple done, got a couple more to go. Okay, so we have top and the bottom. Actually, no, the bottom got messed up. I'll fix that in a minute. There we go. Okay, top and bottom are done. We have 1, 2 done, 2 more to go. Okay. So you basically have two scenarios of this. You can have one where you get all the centers built like this, or you can have all of them are built except one, which is going to be like this, having solid colors. So what you're going to do is you're going to place this center here so it's on top like so. And we're going to place the solid colors so they're horizontal like this. You're then going to perform this algorithm to fix this center. Now the R on this algorithm is going to be the two right layers here. R, U, R prime, U prime, R prime, F, R2, U prime, R prime, U prime, R, U, R prime, F prime. And as you can see, all the centers are now built. Next, we'll build the edges. You'll build the edges much the same way as you would on a normal 4x4. The difference here is that building them means that the edges are like this instead of like this. So basically what we're going to be doing is we're going to be finding a solid white edge and a solid black edge like this. And then what you're going to do is you're going to look on top And what we're going to be looking for is, depending on how these are positioned, we have white on the left, black on the right, we need to have an edge piece set up here that has white here and black here. If this was black on the left and white on the right, then you would have to have it where you have a black piece that is over here and a white piece here. In this case, we have one here that works for the setup. So we're just going to bring this over like so. And we're going to do a horizontal slice move. Bring this up. Bring these over like so. Bring that down. Undo the slice move. And you have your piece here. And these two pieces did not get recombined, which is what would have happened if it was backwards. Okay, let's look for some more. We have white there. Just going to bring that up. And where is the black one? Right here. Bring that down. So in this case, we have black on the left, white on the right. And what we're going to be looking for is we need one that has a black that'll go down here. And I'm looking up here, and right now, there we go, got one right there. So what we're going to do is bring that here. I'm going to do the horizontal slice move. Bring this up. Bring that set over. Bring it down. Undo the slice move. And those edges are all set. Let's see if there's any more. And looks like we have one more set to go. There's the black here, that's the white there. So we have black on left, white on right, so we need a black one, so the black is going there. We have them right there. Bring it up like so. Do the horizontal slice move. Bring that up. Bring that set over. Bring that down. Undo the slice move. And all the edges have now been built. Okay. Now what we're going to be doing is we're going to be rotating the centers so they are alternating in relation to each other. So I'm starting with this, having this piece like so. So you have white here, black here. Ignore what I'm saying when it comes to these because that's what's supposed to be here, not what is actually here. So right now we have white, black. This should be white, which it is. And this should be black. So we turn this like so. And then what we do is we go across instead of down. So we have black, white. We have black here. We have white there. Black. That should be white. Black, white, black, white. That should be black, but it's not at the moment. White, black, white, and black. And what I do is I normally would just do it a second time, make sure I've got everything correct. So we have white, black, white, black, black, white, black, white, black, white, black, white, black, white, black, white, black. So that's all set. So now these are all rotated in relation to each other. So next what we're going to be doing is we're going to begin solving this like a 3x3. And the first part is of course doing the first layer across. So we have this one's good, this one's good, this one's good, but this one's not good. So what you're going to be doing is you're going to be looking to see what one can go up here. So what we need is this one here. What we need is one that is going to come up where it's white here and black there. This one, if it goes up, that black is going to go here and that white's going to go here. That's not going to help us. So we need one that's opposite, like so. And what we're going to be doing here is just bring this like this. That's going to bring that piece over. Bring that over like so. Bring that back. And now we have our cross. Okay, here's another example of having it where you have 3 of your 4 cross pieces are built and this one is not. And what we're trying to do, as before, we're trying to get one of these to go up here. As you can see, this one is going to be the same colors. Black's going to be here, white's going to be there. That's not going to work. So we need one that's going to be the opposite combination. That's the same. That's the same. And that's the same. So when you have this problem, what are we going to do about that? What we're going to do is we're going to take one of the pieces from the center layer and we're going to use this one right here. So we're going to bring this down like so. Bring that over. Bring this back up. And now bring that over like this. And as you can see, that will now work. The white's going to go here. The black is going to go there. So we're going to do our, we'll bring those pieces up there. Bring this over, bring those back, and the cross has now been built. Next, what we're going to do is we're going to be checking the edges here in relation to the centers below. And this one's not good. This one's fine. This one's fine. And this one's fine. So what we're going to do to fix this is we're going to do a technique very similar to what you do with a picture or supercube, which is we're going to perform this algorithm. F2, D. Now you don't need D2 because you're not having to deal with the corners. F, D prime, F2. Now these edges are alternating in relation to the centers, and I'll just usually do a quick double check, make sure everything's good before I continue. White, black, white, black, white, and that's fine. Black, white, black, white, black, white, black, white, black, white, black, white, black, and we're good. So next we're going to be doing the corners. There are two corners here that are already all set. The way you can tell is this should be a different color than these two, which they are here, and here they're the same color. So what we're going to be doing here is, for this one we need the black corner, so we're going to bring that down like so, and we're going to perform this algorithm to place the corner. R prime, D prime, R. We're now going to go to this corner here. This one needs a white corner, which is already in place. So we're going to repeat that algorithm. R prime, D prime, R. As you can see, the first layer is now complete. Now we're going to solve the second layer edges. Turn the puzzle over. And what we're going to be doing is seeing what edges are good and what ones aren't. This one's good, that one's not good, this one's good, that one's not good. Alright. So we have two that are good, two that are not, and what we're going to be doing is we're going to be looking for edges up here that we can bring down. Now this one here, if you look at this, that piece is going to go here, that piece is going to go there, so this edge is all set to be used. You'll be using the appropriate edge turning algorithm, which is going to be the right one for this. U, R, U prime, R prime, U prime, F prime, U, F. And that edge is now in place. We're going to go and go to the next one. And what I'm doing here is I'm just showing a bit of an example of a little bit of an alternate strategy for this, which is in this case, if you use this piece from this angle, this would go here, this would go here, and that's no good. So what you can do instead of looking for another edge, what you can do is just bring this over like this, and this one I'll go here, this one I'll go here, so that's going to be good. And for this you'd use the left edge turning algorithm. U prime, L prime, U, L, U, F, U prime, F prime. As you can see, the second layer is now complete. Next, we're going to be looking at the third layer cross. And you can basically have 4 different cases with this. One is that the cross will be solved, which is not what we have here. What we have here is we have these 3 are correct and this one is not. We'll come back to that in a second. That's the other case. Another case can be none of these are correct. And then you have another where you have 3 incorrect edge pieces and 1 correct one. We're going to be focusing on the correct and incorrect ones because at that point you have what may be the third layer cross edge parity. We're going to have to perform the cross building algorithm a couple times to be sure, because sometimes it will solve itself, but most of the time it will become a parity. So again, we have 3 correct, 1 incorrect. So we're going to be performing the cross building algorithm. F, R, U, R prime, U prime, F prime. Now let's see what we have here. We have 1 is good, 2 is good, 3 is good, 1 is not good. So I'm just going to put this here for the moment. I'm going to perform the algorithm again. Now the algorithm basically still works the same as it normally does, whereas this piece does not move. These pieces do move counterclockwise. But because of the fact that it's an alternating color, and as well as the fact that you have 2 colors instead of 3, again, the reason I say 3 is because 3 pieces move, 1 does not. And we're just going to perform the algorithm again and see what we get. F, R, U, R prime, U prime, F prime. And let's see what we get here. And that's not good, that's not good, that's not good, and that is good. So it looks like we do have the parity. So I'm just simply going to rotate it like this, and I'm going to perform the algorithm maximum 2 more times, but 1 more time just to get it so I can then solve the parity. F, R, U, R prime, U prime, F prime. That one's good, that one's good, that one's good, and that one is not good. So at that point we do have our cross parity. So we're going to put the side with the parity facing you, and you're going to perform this algorithm to fix the parity. And as with a normal 4x4, the M capital R is going to be this middle layer there, and with the M capital L, it's going to be this middle layer on the left. M capital R prime, sorry, M capital R prime, U2, M capital L, F2, M capital L prime, F2, M capital R2, U2, M capital R, U2, M capital R prime, U2, F2, M capital R2, F2. And as you can see, the cross is now built. Now we'll permute the cross. First what we'll be doing is making sure that this center is correctly rotated in relation to the centers below. So we're going to be checking here. We have black, white, and that should be black, so that tells us that this needs to go like this. So we'll double check that, black, white, black, white, black, white, and that's good. Now what we're going to be doing is checking these edges to make sure they are correctly positioned in relation to this. In other words, that the cross is actually permuted. And we'll take a look at that, and it is in fact permuted. And that happens about 99.9% of the time, that once you build the cross, this portion is also correctly permuted. I think I've come across it once or twice in the process of solving this puzzle. If I do come across one where I do need to permute the cross during the course of subsequent solves, I will do a video of that, and I will place it on the channel, so this way we have that. Okay, so the cross is permuted, so that just leaves us the corners. And let's take a look here. This corner is correct, this corner is correct, these corners are not. When it comes to regular 4x4, this is usually indicative of the last layer corner parity. That is not usually the case with this puzzle. Again, I have gotten the parity once in the time that I've been doing this. So again, if I come across it again when I'm solving the puzzle, I will do a video on that as well, but we'll see what we get with this. So what we're going to be doing is we're going to be placing this on the right side like this, with the correct corners. Now the reason that you have it where this has the potential to permute correctly is because of the fact that you are dealing with 2 colors and not 3. Same thing as the other scenarios, because of the fact that this piece doesn't move, but these do, and they're going in an alternate pattern, so that's why it usually will solve itself. So now we're going to perform this algorithm to permute the corners. L prime, U, R, U prime, L, U, R prime, U prime. And as you can see, the corners are permuted, and the checker cube is now solved. In this case, what we have here is we actually have none of the edges being correct when it comes to building the cross. So what we're going to be doing here is we're going to be needing to perform the normal cross building algorithm a number of times in order to build the cross. Although the algorithm will still work the same as it normally does, which is basically this piece is not going to move, these pieces will move, it's still going to take a few times and also moving what piece is going to be on this side in order to build the cross. So again, we'll be using the regular cross building algorithm. F, R, U, R prime, U prime, F prime. And let's take a look what we have. We have one's good, that's not good, that's good, that's good. So what I'm going to do is I'm going to just move this over like this, keep this one here, I'm going to repeat the algorithm. F, R, U, R prime, U prime, F prime. Let's take another look. And that one's good, that one's good. And again, we still have these are being a little messed up. It's going to take a few tries to do this because of the fact you're doing the same, you got different, the way the pieces are alternating because the colors is what's messing that up in terms of doing it easily. So let's do this again. That's good, that's good, that's good, and that's good. Just double check and make sure I've got that correct. I do, so the cross has now been built. And now we're going to be checking the centers again, make sure that they're lined up in relation to these. We have black, white, so that should be black, so bring that over like so. Black, white, and that's correct. So we're now going to take a look at these, make sure these are permuted correctly. And they are, so those are all set. So now we're just going to check the corners because we have the permuted cross, so that's all set. This corner needs to be permuted, that does. Okay, so what we have here is we have our, this one's needs to be permuted, that one is, and basically all four of them do. So basically what we're going to be doing is permuting the corners like we normally would. L prime, U, R, U prime, L, U, R prime, U prime. And we'll take a look, and we have two corners are correct and two corners that are not. And as mentioned previously, just because you have two correct corners and two incorrect does not necessarily mean this is a parity. It could be, but it most likely is not based on what I've been doing. I do get it periodically, but not very often. So I'm going to place this on the right like so, and we're going to permute the corners again. L prime, U, R, U prime, L, U, R prime, U prime. And as you can see, the corners are permuted, and the checker cube is now solved. And there you have it, a tutorial on the checker cube. Thank you very much for watching. I hope you found this video helpful. If you have any questions or comments, please leave them in the comment section below. Until next time, have a great day.